Hi everyone, in this video we're gonna discuss about different type of Apache Iceberg optimization techniques. If you work with data lakes, you definitely face issues like small file problem and also heavy metadata scan and costly table rewrites and also difficult upset and delete operations. But if you check with Apache Iceberg, they have the formatted metadata where the where these problems can be solved very easily, and this makes the data more reliable, scalable and also performant. Coming to the first optimization techniques that we have and we're going to discuss today is small file compaction. What is small file compaction and why we need to discuss about this thing? If you work with streaming data or if you work with frequent upsets that your job is writing to the table, you definitely see this problem, the small file issue. So whenever there is a streaming job or whenever there is again the frequent updates, there are thousands of small files created in your Apache Iceberg table. So Apache Iceberg usually have this concept called compaction. It will compact all your small files into the larger files and optimize files without rewriting the entire table. And why this matters? If you see, whenever the small files are compared into bigger, larger and also like optimized file, it will reduce the metadata scan. It will also reduce your compute and storage cost, and also it will improve the query performance. And this is one of the most, I can say, the important optimization techniques that mostly we perform on the Apache Iceberg tables. And coming to the next we have is the partitioning and metadata scanning. And again, why we do partitioning? Again, to improve the query performance and also metadata, okay, to again the scan the data and to retrieve the files which we require. And unlike high partitioning, if you see the Apache Iceberg, the metadata can store the min and max column values of each file. So again, why we are storing this thing? If you ask me, the main concept is whenever you try to read a Apache Iceberg table, first it will go to the metadata. So it will go to the metadata. When you have the minimum and min and max files of each column values, it will skip the irrelevant files and it will only scan the files which we required. And it again, this drastically improve the IO operations and also improve the query performance. And the third thing is we have the snapshot management. So what is snapshot management? If you ask me, whenever you write any data file to Apache Iceberg, it will create a snapshot in metadata folder. So when the snapshot is created, usually the snapshot is used for the time travel, rollback and also consistent reads. And the snapshot management is simply cleaning the expired snapshot and also removing the unused files in the metadata layer. And the fourth and important thing is the efficient deletes. So whenever you are doing upsets or delete operations on Apache Iceberg table, Apache Iceberg handles very differently using the delete files. So usually it will, whenever you upset or delete, it will not rewrite the entire file. First, it will mostly handled by the deletes file separately. So while reading the file, you can able to get the files which are deleted. I mean you don't see the data, but when it later it will merge by compaction. Usually like background, like when you're not writing the data to Apache Iceberg tables, you can perform the compaction on your Apache Iceberg table. So mostly, like, to summarize all the things, we have the four different optimization techniques that we mostly perform on Apache Iceberg tables. One is the small file compaction, and also the second thing is we have the partitioning and metadata management, and we have the snapshot management and efficient deletes. So by using this all optimization techniques, we can make the Apache Iceberg more performant, and also we can reduce the compute cost and storage cost, and we can improve the query performance. And I hope you like this video. Thank you.